Okay, so here's an update on our SEN6x Sensirion sensor. A little mistake that I made in the first video, which I'll just correct, is that the SEN6x should be powered by 3.3 volts. Its maximum voltage is 3.4. Surprisingly, it did actually run for me at 5 volts for over 24 hours and seems to have not been damaged. So kudos there to Sensirion. It didn't get fried. My mistake for not reading the datasheet properly. It's 5 volt tolerant on the I2C pins, but the power is 3.3. So I've got it hooked up here now in quite a little complex little setup, and I don't know if I'm going to be able to cover all of this in the one video, but basically we've got the SEN6x doing air quality measurements. We've got a radio transceiver here. This is the 433 megahertz, I think it is, transceiver that we're using there, and we are collecting data wirelessly from a DHT11 sensor, which is broadcasting wirelessly from my other Arduino over here. We've got an OLED display setup which shows the values that are coming in. We've got a little traffic light sensor here, which goes green, yellow, and red, depending on CO2 or air quality levels. And we have a buzzer, which will sound only if CO2 is high. So this is all working pretty good, actually. So I'm receiving data from this. I haven't done a range test yet. We'll do that in another video. But, you know, it's relatively close together here. But I've got a wireless signal. We've also got our Arduino R4 connected up via Wi-Fi, and all of the data that's being collected from the SEN6x is being communicated over MQTT to a cloud broker called Hive, and then from there I'm graphing the data in Grafana and sending it all out to a Kafka cluster database. So we've got quite a lot going on here, but you know, once you learn these basics of doing this, it applies to all kinds of systems. You know, it doesn't have to be a SEN6x sensor, it could be anything. But basically, what I'm doing is learning how to do all of this so that we can go on to some more advanced projects. But what we're going to cover in this video is effectively how I got the basics of this working with sending data over MQTT. In our previous video, link in the description below, I was showing you how to get data out of the SEN6x via I2C into your Arduino. Now we're going to do something with that data. So here is the data coming from the SEN6x into Grafana. There's a little bit more to it though than just simply telling Grafana to make a graph, obviously. So we are sending the data over MQTT, and that is going to something called Hive. So this is our MQTT broker here. I can clear all messages, and then you'll see every time the Arduino broadcasts, we'll see our messages come in here. So these messages, they're not stored. There's no persistence here. They come in, and then they're sent out to whoever's subscribing to that topic. So to get persistence, we've got Confluent, which is a Kafka database, which is basically getting that data. So it subscribes to the MQTT stream. So anything that comes into Hive will get published to here. And from here, it's stored. You see we've got a retention time of 1 month. You can change that to be longer or shorter. And then when we go to Grafana, we'll be able to have a complete graph. At the moment, you'll see there's a gap. And this is because if I refresh this page or leave this page, then when I come back, it'll be starting from 0. Because this at the moment is connected directly to Hive, and it's just getting whatever Hive receives, and it's not being saved anywhere, okay? So we need to connect this to the database. So the next thing, which I haven't done yet, is connect this up to Confluent. The object of this tutorial, though, is going to be to focus on how I'm getting this data via MQTT from the Arduino. So this is our complete Arduino code, and you can see it's quite complicated. We've got a lot going on in here because we've got Wi-Fi connection, we've got our OLED display, we've got our wireless radio connection, and we've got the MQTT running. So what I've done is I've made a simplified sketch which just focuses on the Wi-Fi connection and the MQTT part. So let's just take a look at that. Now what we're going to do is we're going to go through basically live. So hopefully if I come into any errors, then we're going to solve them together. So this is our MQTT code. So what we've done, have to done first of all, is we need to install the pub sub client, which you go over to libraries and you search pub sub client. And from here, you're going to install it, and I've already installed it, so I don't get the install button. And then you're also going to need the Wi-Fi S3. And you're going to need the Wi-Fi SSL client. Okay, so you're going to install all of those, and then we're going to import them or include them in this sketch. Okay. Now you see I'm including something else here. This is a file here called secret. So to make that, you're going to go up here and go to new tab. And you'll create a new tab and you'll give it a name. And basically this is where you're going to store your secret password. So not exposed here in the code. So that is our SSID and password to join our Wi-Fi network. Okay. Now you'll see under here we've also defined our MQTT server username and password. Those say something at the moment. We don't know what that something is yet. And this also should be something for now. Okay, so we're going to need to fill those in. First, let's take a look at the Wi-Fi section. So we are going to define that the pub sub client, which is our MQTT client, is going to connect over SSL. So it uses the Wi-Fi SSL client, which we're going to call SSL client. Pub sub client is going to use the SSL client. So basically, this is key because Hive uses SSL, so you need this to be included. Okay, then we have our connection part here. So while the status is not connected, then we're going to print to our serial that we're attempting to connect to the SSID. Okay, and then we'll print the name of the network we're trying to connect to. Then, if the Wi-Fi has begun, if it's actually connected, then that's good. We'll continue. I do have a delay here for 10 seconds to wait to allow for it to connect. And then if it's not connected, start again. So basically every 10 seconds it will try and connect. Then we'll print, if we're connected, that you're connected to the network. And we'll print the Wi-Fi data and the current network that we're connected to. Okay? So these are our Wi-Fi connection functions. This is going to be called when we start up. And then we have our MQTT functions. Okay, so we have an MQTT callback function. We have a reconnect function. And then we have some more Wi-Fi stuff here. So this is printing of the Wi-Fi connection information. So moving down to here, we have the code which runs once when we start up. So when we start up, we're going to begin serial connection. We're going to have a 500 millisecond delay. And then we're going to print MQTT TLS example. We're then going to call the setup Wi-Fi function that we defined earlier. And then we will connect our MQTT. Then we have a loop. So if the client is connected or not connected, then we will call reconnect. And we will reconnect the MQTT. And we'll keep on looping that until it connects. And then if the string is available in the serial, then we're going to publish that string over MQTT. So it's client.publish, and then the topic that we're going to send it to, and then the message, which is our string from above here. And then if the Wi-Fi status is not connected, then again, we call the setup Wi-Fi function. And at the end of that, we wait 100 milliseconds. So this will keep on looping. So basically, every time we type something into the serial and we hit enter, then it is going to broadcast that to our MQTT broker on this topic. Then it will clear the serial display and we can do it again. And then if at any time our Wi-Fi becomes disconnected, we reconnect. Now we need to go over to Hive and we'll create a cluster. Okay, so I'm going to create a serverless free cluster. That'll show up here. So now they're both running. Now I need to check which one is which. Okay, so this is our new one here that we just set up. Okay, so we're going to need to create a user first of all. So we'll go to add credentials. Username will be testing. They can publish and subscribe. And our password will be Science Sidekicks. Sidekicks, and we'll confirm the password Science Sidekicks. Okay, so we save that. Must have at least one digit. Okay, so we've got Science Sidekicks 1. Save. So now we have a username and password that we can input here. So remember up here, we have an MQTT username. So that will be Science Sidekicks 1. Sorry, that's our password. Our username is testing. Let me check. Did we use a capital T? Yes. So testing and Science Sidekicks is our password. Next thing, we go over to overview. And you'll see here we have a TLS MQTT URL. And we have a plain URL and a port number. So this is the one that we're going to use. So we're going to copy that. And then over where we had something for the server, we're going to paste that in. And then underneath, MQTT port is 8883. So again, we can copy the port number. And put that into here. Okay. Now the Wi-Fi SSID and password we already have in our Arduino secrets. So you would just go into there and you would edit that to be whatever your SSID and password is. So now we have this done, we should be able to run this. So we will upload this to our Arduino R4. And we'll open our serial monitor. Check that. Okay, I'm just going to unplug the board and plug it in again. That sometimes makes a difference. There we go. Okay. So it's connecting, you can see here, to my network SSID. We're connected. Then it will wait 10 seconds or so, and then connect to the MQTT. And we're connected there. Now we'll go back over here into Hive and we go to our web client and we will log in here with testing and the same Science Sidekicks, and we'll connect. Science Sidekick. Make sure that we got this correct. Just try connecting with auto-generated credentials will do for now. Okay, and we'll go to subscribe to all messages. Okay, so we'll go back over here into our Arduino. Now we're going to enter a message in here. So we'll say testing MQTT. Now when we enter, there we go. You'll see it came up here in Hive. So we have established an MQTT connection to Hive from our Arduino. And you can see it's pretty responsive. Doesn't take long for it to show up here. So it's very fast communications between these two. Okay? So that is the basics of how we get MQTT set up on the Arduino, broadcasting a message. Now, obviously it gets more complicated than that in our Sensirion air quality monitoring sketch. It's a bit more complicated because we're sending a lot more data, but that is the basics of it. So I will, as I say, put a link in the description below for you to download this MQTT connection test. And you can go over to Hive and you can input your own details and get started sending data from your Arduino over MQTT. So I hope you enjoyed this short video on how I'm connecting up my Sensirion with the Arduino and getting the data up on MQTT. Don't forget to like and subscribe, and see you in our next video.